2017 Connected Particles, question 4a. Two scale pans A and B, each of mass m kilograms, are attached to the ends of a light inextensible string which passes over a light smooth fixed pulley. They are held at the same level as shown in the diagram. A mass of 3m kilograms is now placed on A. The system is released from rest and you're asked 3 questions. Find the tension in the string in terms of m, how far B has risen when it has reached a speed of 0.4, and the reaction of the 3m kilogram mass in terms of m. Okay, let's look at the forces at play here. We have A and B. I'm just going to make them rectangles. So they're both m, but 3m is put on top of A, so that makes A 4m. B will still be m, so the acceleration is going to be down in this direction. So 4mg coming down. I have a tension in the string going up. So my force is equal to ma equation will give me 4mg, because that's the direction it's going in to begin with, minus t is equal to 4m times A. And for the m pan, move the tension, we've got mg going down, and this one is going up with an acceleration of A. So starting with the direction it's going in, t, we're going to get t minus mg is equal to ma. So if we bring this one across and put the t under the t, we get minus mg plus t is equal to ma. So 3mg is equal to 5ma. The m's will cancel, so A becomes 3g over 5. And on this side, tension, we're looking for tension. Tension is equal to ma plus mg, and we're asked for the tension in terms of m. So the tension is m times 3g over 5 plus mg. So the tension is equal to 3mg over 5 plus mg. So that's 3/5 of mg plus a full mg, which would be 5/5. So the tension is 8/5 or 8mg over 5. And that is in newtons. Part 2. How far has B risen? Okay, S. We're looking for S for part 2. And we're given the speed. When it reaches the speed, we're given V as 0.4. We know the system was released from rest, so U is 0. And the one other variable that we now have is A, which was 3g over 5. And because you've practiced these questions so often, you know the equations off by heart. V squared is equal to U squared plus 2AS. V squared, we have V, 0.4. 0.4 squared is equal to 0. Plus twice 3g over 5 times s. We will divide 0.4 squared by 6 by 9.8, 6g, 6 by 9.8 divided by 5. And that will give me s. So just one step calculator use. S is equal to 0.013605, so just 36, and that it would be in meters. So just 1.36 centimeters, a tiny distance. Part 3, we're looking for the reaction of the 3m kilogram mass. Now I kind of cheated over here a little bit by just putting them into one. 3m kilogram mass, we have our m, and if we imagine it's nearly the same size, we have our 3m on top. So let's look at what's happening with this 3m. We have a reaction. It's not connected to the string because it was placed on top. We have a force going down, which is 3mg. The acceleration It's going in the same direction, obviously, so acceleration is going down that way. So this should enable us, let's call this reaction, or because that's what they're looking for here. So we have, again, force is equal to mass times acceleration. In this case, we are going to get, it's going down, so 3 mg minus r is equal to 3ma, or 3m. Now we have a, what do we get for a? 3g over 5. So r, we bring it across to the right and make it positive, is equal to 3mg. 3mg minus 9mg over 5. So in fifths we have 15 mg minus 9 mg over 5. So 15 minus 9, that would give a reactionary force of 6 mg over 5. And again, that's in newtons.